The Millennium Seed Bank project builds on Kew's experience of over 30 years at collecting seeds of wild species and conserving them in a seed bank for many years as a hedge against extinction for conservation purposes. The project you see now took off with the award of Millennium Commission money in the late 1990s. We've been in this building since 2000. Our current aim, as well as collecting seeds from all the seed-bearing plants in the British flora, is to collect 10% of all those species worldwide, especially from areas with significant drylands in the world. What we do to the seeds in the seed bank is not rocket science. It's largely like food technology. To preserve them for a long time, we dry them and we cool them. And the first thing that happens to seeds when they come into the seed bank is they are dried, because that stabilises any ongoing loss in viability. It also prepares them for the next stage of the process, which is cleaning. The cleaning process is largely a manual, careful activity. It has biblical simplicity. It's threshing and winnowing. We dry seeds and fruits. We push the fruits through variously sized sieves to achieve separation. They're pushed through carefully with rubber bungs, and the resulting mix of wheat and chaff, if you like, is then blown in various aspirators that we have in the laboratory to remove the light, empty seeds and chaff from the good seeds which remain at the bottom of the column. After the seeds have been cleaned, they are re-dried, and just like the initial drying that happened before cleaning, the drying we carry out is passive. That means they are left in an environment of something like 15% relative humidity. Now, that's the same relative humidity as Death Valley in California, but the temperatures we use are slightly lower. Just to walk into the dry room and breathe through your nose, you can feel how dry it is in there. So we re-dry the seeds before they are then packaged in a number of different kinds of containers, various sized glass containers, including parfait jars, just like the Women's Institute use for their preserves, depending on the size of seeds and the total size of the collection. They're then ready to be put into storage. The storage itself is at -18, -20 degrees Celsius. That's standard deep freeze technology in a number of cold chambers that we have in the vault at the Millennium Seed Bank. When we talk about viability, we mean that if we put 100 seeds to germinate, a very high proportion, greater than 80 or 90%, will be alive. They will germinate. They're alive, capable of germination. There's no point in storing seeds if you can't get plants back from them. What we want to do every now and again is to test their germination. We need to have good germination tests worked out for all our species, and that's quite a tall order because in nature there's such variety, and evolution has come up with a number of strategies in wild species to make sure that a population of plants doesn't put all its eggs in one basket and germinate all at once. Many wild species possess various levels and various mechanisms of seed dormancy. Now, if we put 100 seeds on a petri dish of agar, which is what we use, and only 50 germinate, that could be because 50 are alive but dormant, and we need to work out how to make those other 50 germinate and thus get the full genetic potential of the population of plants from which the seeds were collected. Or 50 are dead, and we need to know the difference. A lot of our research work is involved with understanding germination, understanding dormancy. On top of that, the great variety of species with which we deal have seeds which vary tremendously in their capacity for storage in a seed bank. First of all, there are species like many tropical forest trees, and also in the UK, oak and horse chestnut have seeds that you cannot dry, so you cannot put them in a conventional seed bank. We've got to look for other methods of preserving those seeds and embryos. One particular discipline that we have in the Millennium Seed Bank project is to be able to study seed morphology. The size and disposition of the embryo within the seed can tell us something about how slow or how difficult germination may be for a particular species. For example, palms, often very slow to germinate, not always, but often. As I've said earlier, there's no point in storing seeds if you can't get plants back from them. We want to see the seeds from our seed bank used, and used they are. We have an online seed list to which researchers and others can apply to have small samples of the seeds, which they put to all kinds of uses. But also we're increasingly growing seeds into plants for revegetation, restoration. We have already populations of plants grown from our seeds under glass here at the Millennium Seed Bank that are ready now to go back into the wild, into countries where they were under threat, and they still are under threat, but at least we want to promote more and more the concept of restoration and recovery.